Waste incineration. Chronic poisoning of the people, Part 6. Total dust. According to Section 5, Part 1, Number 1 of the 17th Federal Ambient Pollution Control Ordinance, 17th BImSchV, the parameter total dust is to be observed continuously. Now, daily average value may exceed 10 milligrams per cubic meter. Now, half-hour average may exceed 30 milligrams per cubic meter. But how is total dust defined? One would think it is the total amount of all dust particles, no matter how small they are. Critics asked for more details. Does this refer to the coarse dust? From what particle size on? 20 micrometers, 10 micrometers? Are fine respirable dust particles from 0.1 to 10 micrometers diameter included, or even finest dust less than 0.1 micrometers in diameter? Total dust is a more or less antiquated technical term. The German TH Luft, established in 1974, distinguishes between total dust and fine dust and sets a particle size of 10 micrometers as the upper limit of fine dust. Hence, the meter parameter total dust comprises mainly coarse dust bigger than 10 micrometers. The continuous observation of the dust fraction is the most convenient for measuring purposes. Today we know that fine and finest dust is considerably more relevant or health than coarse dust. Particles of fine and finest dust are still big enough to effectively transport very problematic molecules of heavy metals, dioxins, or asbestos fibers. In the context, Dr. D. H. Buss emphasized the special danger of contaminated nanoparticles due to their high mobility in tissues and cells. A more diversified categorization of the quality of dust emissions should have been established with the update of the 17th BImSchV in the year of 2003 at the latest. Today we have a demand of definite quality features of laws and regulations targeting the damaging effects of flue gas, the detailed assessment of coarse, fine and finest dust, if necessary also ultrafine dust, and their distribution according to particle size and chemical composition. Temporal and local fluctuations of dust charges in the large cross-sections of the flue gas streams occurring in waste incineration plants also should have been considered in the present legal and technical standards. Suitable recommendations and measurements procedures are definitely available as described below. But apparently it was convenient to use the word total to let the people think that the total dust emission of modern waste incineration plants are insignificant. Organic substances denoted as total carbon. Another parameter is called organic substances denoted as total carbon. Similar to dust, it should also be observed continuously according to the 17th BImSchV. Now, daily average value may exceed 10 milligrams per cubic meter. Now, half-hour average may exceed 20 milligrams per cubic meter. It sounds like this parameters sums up all emitted hydrocarbon compounds. But the meaningfulness of this total parameter is open to doubt too. The word thought doesn't even exist in the 17th BImSchV. Apparently, it cleans bill of health. Image would be disturbed. Detailed analysis brought to light a considerable line-up of hydrocarbon, benzenes, phenols, aldehydes, and the halogenated derivatives, polychlorinated biphenyls, PCB, as well as some polycyclic aromatic hydrocarbons, PAK or PAH, respectively, which unfortunately are not directly monitored under the 17 BImSchV. Professor Dr. Ottmar Wassermann, toxicologist from the Kiel, Germany, provided evidence of a variety of organic substances, among them very problematic ones, when his team analyzed samples using different methods. Dr. Kruse confirmed these results during a German TV show monitor last year. It was last year, 2007. But again, the choice of the words originally bound total carbon in combination with a low critical value helps to play down the noxious relevance of waste incineration plants emissions. Professor Wassermann graphically illustrated the minimal significance of the stipulations contained to the 17th BImSchV and the dangerous black box character to flue gas from waste incineration plants by comparing them to a deep black spot that's brightened up just a little by the clean bill of health presented by the 17 BImSchV. You see this figure 5 here in a stay picture in the video. Suitable verifications procedures for further elucidation of the black box have been developed long ago, but it seems that for marketing reasons it wasn't opportune to properly include them in the 17 BImSchV. With one exception, polychlorated dioxins, furans, PCCD, PCDF, which are recognized as super poisons by the public. For this group of 210 different substances, so-called congeners, a very strict critical value less than 0.1 nanograms per cubic meter was determined. But which kinds of dioxins furans actually are meant remains unclear. Really all of them, like those on soot particles where they mainly can be found, or only those in the water vapor-rich gas phase or flue gas where the hydrophobic molecules they hardly occur at all. So the description of this picture is: share of pollutants in flue gas of waste incineration plants analyzed in compliance with 17th BImSchV, visualized as a white spot on a black ground according to the toxins Professor Dr. Wassermann Kiel found in the flue gas of incineration plants. The polychlorinated dioxins furans PCCD, PCDF. The real problem of dioxin measurement begins previous to the analysis. It has to do with the extremely high adhesion, especially of the most poisonous dioxins, the so-called Seveso poison, to the surface of fine dust and soot particles. Nobody can say for sure that routinely conducted elution and extraction really completely bring all 210 possible dioxins furans out of the dust and soot. Due to its high adhesion, a considerable uncertainty factor remains. The amount of emissions is underestimated. In other words, the technical analysis method itself, the high-resolution gas chromatography and subsequent mass spectrometry are highly developed and provide reproducible results. But a considerable amount of dioxin molecules cannot be measured since they remain in the nooks and crannies of the rough surface of dust and especially soot particles, in spite of the use of elution technique. In cooler areas of a furnace and during a cool-down phase of flue gas cleaning, these molecules are driven with a very great force into the deepest process of the fine dust and soot particles. There the planar and symmetrically molecules adhere almost inseparably. A comparison with the structure of the famous natural dye indigo, which still shines in intense colors even in ancient and often washed Persian carpets, might be helpful. The error is not reduced by subsequent addition to the sample of an eternal standard, C13 mark dioxin congeners, as quantitative reference value, because these standard substances can much more easily be eluded than the dioxin furans driven into the dust and soot particles in the waste incineration plants. Hence, the gas chromatographic peaks of the sample usually are too low compared to the peaks of the standard substances. They are actually wrong, even if the analysis after extraction was carried out accurately.